Good morning. Alright, so now we're moving on to week 3, day 2. And all of these are going to be the word problems. And what you're going to be needing to do for these word problems, since they're distance word problems, is to use this formula for distance. Rate times time equals distance. Okay, so we're going to be using this to help us write our equations to help us solve these word problems. Now what you're also going to notice, what's common among these problems that we're going to do today is, and you can do for homework, is that we're going to be setting up a chart or a table. Okay. Alright, so let's take a look here. So we have Natalie left Sarah's house and drove north at an average speed of 70 miles per hour, or kilometers per hour. Sometime later, James left during driving in the opposite direction with an average speed of 20 kilometers per hour. After Natalie had driven for 3 hours, they were 250 kilometers apart. Find the number of hours James drove. Okay, so with that last statement, we are going to define our variable x to represent the number of hours that James drove. Okay, so we always want our variable to represent ultimately what we're looking for. Again, in this case, the number of hours James drove. Okay, so that's going to be x. Now, as I said before, we're going to set up a table or a chart. So we're going to have 2 rows going across, one for Natalie and one for James. And then we're going to have 3 columns going downward this way. One column is going to be labeled rate, the other time, and the last one is going to be labeled distance. Okay, so we're going to fill in this table based off of the information that's given in the word problem. Like, for example, we know that Natalie is going at an average speed of 70 kilometers per hour. That's a rate, so that's where we put 70. Under the rate column in Natalie's row. Okay. Then sometime later, James left driving in the opposite direction. We'll take care of that in a minute. With an average speed of 20 kilometers per hour. That's a rate. And that's James' rate. So, in the James row, rate column, we're going to put 20. And it says here, after Natalie had driven for 3 hours, they were 250 kilometers apart. Again, we're going to need to find the number of hours James drove. Okay. Alright, so now you notice that we put the 70 and the 20 in the respective places for Natalie and James under the rate column. Now we're going to fill in the time column. That's the time driving. So we know here that Natalie drove for 3 hours. And that's why I have 3 in this box. We're going to put x in this box for James's time, because again, we don't know how long James has been driving. So that's our x. Now you may be wondering, where did these 2 entries come from in the distance column? Well, if you look at the rate and the time value, when I multiply those together, 70 times 3 is 210. 20 times x is 20x. Now you may be wondering, so why did I multiply those? How did I know I have to multiply those? Well, if you recall, when we started off this video, I said we're going to be using this rate times time equals distance formula. Okay? So the way I'm getting my distance values in these boxes is I'm multiplying whatever is in the rate column times whatever in the time column. So again, that's how I'm filling in these boxes. I'm multiplying the rate and time values together to get these expressions or values for distance. Okay? Alright. So now we need to write our equation. Because we're only using one variable, we only need to write one equation. And if we were somehow using 2 different variables, then we would have to write 2 equations, and that just gets it to be more complicated. Right? One equation is all we need. So the thing about these problems is that we're not going to use all of the values in this table. We're only going to use the ones that we need. And if you notice that the only thing that we did not use from the word problem is this value right here, 250. Specifically, that's 250 kilometers. Now that's a distance, right? So we're going to write an equation that uses this value, right? 250 kilometers. Well, because that's a distance, that means from our table, we are only allowed to use what's in the distance column. Right? So if we're going to use 250 kilometers in our equation, we are only allowed to use what's in the distance column. Well, according to this chart, Natalie traveled 210 kilometers. Okay, so I'm going to write down her distance. James traveled 20x kilometers. So I'm going to write down his distance. Now, because they're traveling in opposite directions, right? This is where you got to understand this. For the opposite direction word problems, we are going to add these together. Okay, so I'm going to take Natalie's distance that she traveled and James's distance that he traveled. We're going to add those together. And what are they going to equal? That's right, 250 kilometers. So there's our one equation that we're going to be able to solve for x. Right? So I'm going to subtract 210 from both sides, divide both sides by 20, and I get x is equal to 2. All right? So we know how far, or how long James drove for. He drove for 2 hours. All right? Okay, so I want you to try your hand at number 2. So define what your variable represents and make a table or chart. Fill in the blanks with the information that you're given. Okay, and then fill in the rest based off what you know from our little formula here for distance. Alright, so you should let x represent the number of hours the passenger train needs to travel in this problem. Ultimately, that's what we're looking for, right? How many hours the passenger train travels. Alright, so take a look at your table and see if you filled in the table as I did here. Alright, so we know that the freight train travels at 10 miles per hour, and we know that the passenger train travels at 90 miles per hour. Again, x is going to represent the number of hours that the passenger train travels, so we're going to look at the x. Now, what could be different from my table than what you have is that I have the time for the freight train be 15 plus x. We know why that should be 15 plus x. Because the most common mistake here is that a student's going to put here 15. Right? So we see here a freight train left and traveled north at an average speed of 10 miles per hour. A passenger train left 15 hours later. Okay, so that means that the freight train got a 15-hour head start before the passenger train left. So that was 15 additional hours. So this is 15 hours later. It doesn't say that the freight train traveled for 15 hours. It said that the freight train or the passenger train left 15 hours later than the freight train. So that's why we have this expression for time to be 15 plus x. Okay. Alright, so now that we've filled in the rate column and the time column, just like the previous problem, we're going to fill in the distance by multiplying the rate times the time. So 10 times 15 plus x, 90 times x, 90x. Okay. Again, this is another traveling in opposite direction. So we said for the opposite direction problems, we should be adding those boxes in that distance column, and that's going to equal the 550 miles they are apart. Okay. Alright, so I think for the interest of time, I'm not going to solve these all the way through. And you should be able to solve these. Again, simplifying the expressions, combining like terms, solving for x. Okay, so for the rest of these problems, we're going to go ahead and just get to the point where we get to the equation. Okay, so let's take a look at number 3. So a passenger plane left 1 hour before a cargo plane. The planes flew in opposite directions. The cargo plane flew at 160 miles per hour for 8 hours. After this time, the planes were 3,710 miles apart. What was the passenger plane's speed? Alright, so we're going to let x again represent, well, ultimately what we're looking for, which is the speed of the passenger plane. We're going to set up our table. We got a row for the passenger plane, one for the cargo. We got rate, time, and distance. Alright, so we are looking for the passenger rate. Again, that's x. That's where x goes. It's about x represents speed. The cargo, we know, is going 160 miles per hour, so we get 160 here. Alright, for time, we know that the cargo plane was going for 8 hours. So I'm going to fill in 8 for the cargo's time. Where I got this 9 from was from the first sentence, where it says the passenger plane left 1 hour before the cargo plane. So that passenger plane got a 1 hour head start. So if the cargo plane was going for 8 hours, that means the passenger plane was going for 9. Okay? Alright, again, we fill in this last part of the table by multiplying whatever's in the rate box times the time box. So x times 9, 9x. 160 times 8 is 1,280. Okay. Because we have this distance, and we see that, again, opposite directions, that means we're taking our distance value, so 9x, add it to 1280, and that's going to equal 3,710. Okay, so again, for that, you're going to go ahead and solve for x, and that would be your answer for the speed of a passenger plane. Alright, so we're going to pause the video and see what you can do with number 4. Again, setting up the table, using rate times distance, rate times time equals distance. Alright, so for number 4, we have a freight train going to Johannesburg and back. Going there, the train traveled 32 kilometers per hour, and returning went a little faster at 40 kilometers per hour. So they're asking us how long did the trip going there take if the return trip took 12 hours. Okay, so we're going to let x represent the time to travel going there to Johannesburg. Okay, so x is a time value going there. So here I got one row going there to Johannesburg and a row for returning from Johannesburg. Again, going there, we had a rate of 32 kilometers per hour, return rate of 40. Here's our x for the time going there. And it took us 12 hours to return from Johannesburg. Okay, so again, I filled in these 4 boxes as we did with the previous examples. Again, this last column came from us multiplying the rate times the time. 32 times x, 32x. 40 times 12 is 480. Alright, so now we need to figure out where we're going to write our equation. Well, our equation is going to come again from this last column. But you notice, unlike the previous examples, we do not have any other information regarding distance. So this is one of those problems where we have to kind of think a little bit. Right? The distance going there and the distance returning are the same. Right? They are equal to each other. Again, we're going, right? So say, for example, if you are going to walk from your house to your friend's house and then back to your house, right, the distance traveled is exactly the same. Same thing here. So I'm going to take the distance going there and I'm going to set it equal to the return distance. Because we're going back and forth between 2 points, 2 cities, that distance is going to be the same. So that's why we set these expressions equal to each other. Again, you're going to go ahead and solve for x. Okay, so I want you to now move on to video number 2 that goes over the last 3 problems from this note sheet. Okay, so move on to video number 2 for this day's lesson.